Hello YouTube. So I recently hit upon an interesting little problem that I thought would be fun to code. So let's make a new project called How to Prioritize. And let's open it up. So here's the problem. Suppose I have a number of projects. We call them A, B, C, D, and E, and F. How do I know which one to do? So that's the problem of prioritizing, let's say. It could be anything else. It could be which thing to buy or which house to buy or something like that. But just how, given a number of items, how do we prioritize them? Now the silly implementation is, let's say you cannot define a number that you give to each project or each item, but you can compare items. So I can compare A with B. Let's write it like that. And that returns, for example, A has higher priority in B than B. And then I could, keep doing that. And so on. Compare A with everything, B with everything, C with everything, and so on. And in the end, I will have some list that is like, maybe it's like this. But that's kind of silly, because there's a lot of information that I'm not using or that I'm calculating twice. For example, I know A is more important than B, and I know that C is more important than A. So I don't need to do this comparison, right? Because I already know that B is less important than A, and A is less important than C. So I don't need to do the comparison. I already know that this is true. So that's the whole point of this. Given like the least number of comparisons, how can I find this priority list? And my idea to solve this is, let's make a table like that. And it will also have A, B, C, D, E, F here. And the table is the comparisons with each element with the other elements. So it doesn't make sense to compare an element with itself. So we can put x's here. And then we compare A with B. And let's say we put a 2 to mean that A is more important than B. Then here we have to put, let's say, a 1 to indicate that B is less important than A. And now when we then compare A with C, we find a 1, and then we can also put the 2 here. And then the idea is that we propagate the information we already know. So it's kind of like a constraint propagation algorithm. So we have the 1 here, and then we look at the information we have about A, and we see that, okay, there is a 2, which means that there should also be a 1 here. And so basically, since we know this, then everything that goes here, we also want to put this. So that's the first part of the algorithm. Everything that's less than A, we also want to put that into C, mark that as less than C. And on the other hand, everything that's greater than C, we also want to put that as greater than A. So that's the basic algorithm. Now, let's start by defining how this table should look. So let me do it like that. let's call it a comparison table. And it will just have some comparisons, which should be a table, basically a 2D array. So let's make a vector. And just for fun, let's do this. So we will have an equality, or let's say unknown, and then greater than or less than. And then the comparison table keeps a 2D array of these orderings. Now, let's do a little bit of implementation. Let's make a new function. So, actually the new function should probably take an argument, which is how many elements do we want to compare. So let's do an I32 because why not? And then we want to make a 2D vector with this dimension. Okay, so let's make the table. It's a vector. And then for, let's say, row in this, and it should be a mutable table. We push, or let's say row index, and then the row is also a vector. And then say for column index, then we want to push a unknown ordering. And once we have made the row, then we push the row into the table. And that should do it. Then we can simply return it. Let's try to make one. Let the comparison table equal comparison table new, and we will for sure need some derives, but let's just let the compiler tell us what we need. Okay, so odd is ambiguous. Okay, probably there's something else called odd, so we will call it ordering instead. Okay. This function takes one argument, but 0 arguments were applied. Okay. Let's say it's 4. It's 4 elements. Comparison table does not implement display. Let's do that, but I will do it off screen, just to spare you the details. Okay, and here is how it looks. You implement display for the table. You just have to have a format function, and in the end you call this write macro on the formatter that comes into this format function, and then the way I've done it is I construct a string that I want to be the representation. Now, and to do this, I also implement formatting for the ordering. If it's unknown, I put an X. If it's greater than, I put GT, and otherwise I put LT. Maybe I put a space here so they have the same length. And then if I run this, then when you construct the table, it looks like this. And now let's make it mutable, and then we say comparisons 2 is greater than, and we print it again. and then it says GT. So that seems to be working. Now let's start filling things in. So how do we want to do this? Now there's a lot of junk that I don't want to look at. Oh. Let's put these display things. Can I put them down here? Still seems to work. And now let's implement some ordering function. So what do we want? Let's say I call it add, and it needs a mutable reference to itself because it's changing the comparison table. And then we want to have two elements. Now we don't have any type for the elements. Perhaps you could make this generic. But for now, let's just say I32. That we have two elements identified by their index. And then we want a compare function. Let's call it CMP. And I think it needs to look like this. So we want to take two I32s, and then we want to return an ordering. And it should compare the first with the second. Has no return value. Let's see if that runs. Yeah, that's what I thought. Okay. Great. Unused variables. Let's also allow unused variables. Variables. That didn't work. Also, the other one didn't work. I guess they only apply to the thing right below, which is a little bit annoying, but okay. Anyway, let's get started. So let's say we have the value, which is compare these two, and then so also this compare thing could be something, if you like make an app or whatever, could take input from the user. So let's say we compare, and then we say the comparisons, element 1, element 2 should obviously have that value. And then we want to say something like, so if we have greater than, that means element 1 greater than element 2. And anything else is a panic. So it's probably a better way of modeling this, but let's, I don't know what it is right now. Let's write every element must have a known ordering. Known ordering. Okay, great. Now what do we want to do in here? We want to say take all elements greater than element 2 and fill them in for element 2. Take all elements less than element 2, fill them in for element 1. Great. Now at this point we could also check for consistency, because if you just ask randomly, then you could give inconsistent answers. But we could also assume that the person using this only asks for unknown things, and then there should never be an inconsistency. So let's say greater than element 1. We need a new method that says greater than, and then we give element 1, fill them in for element 2. Then we say, let's call it fill. Okay, greater than element 1, and we need to fill greater than. Then we can do the same here. Okay, let's try to implement those functions. Greater than, it can simply take a reference because it's not changing anything, and it should return, let's say, a vector of indices. And it should of course also take the element. So let's say the relevant row should then be the comparisons for that element, and let's make a result variable, whatever, which is a vector, and then we say for, let's say the dimension is row dot length, and then we say for index in 0 to dimension, so we loop over all the elements. Now, if the index is equal to the index we're looking at, then we just continue. Otherwise, if the value is equal to greater than, then we want it. Then we want the index. And in the end, we just return the result. Okay. Let me write a test for that. Okay, so when writing the test, I just ran into some problems. So to index a vector, we need a U size, not an I32. So just to make things easier, I've just changed all the types to U size. Now we also need to be able to compare ordering, so I derive partial EQ, whatever, partial equal. Then I made some stubs for these functions that we will need later. So it compiles. And now there is another error here, use of moved value, line 56. And what does it say? Move here, because type ordering does not implement copy trait. So we'll do that, and then it will tell us that we need to implement clone. I don't really understand why you always have to implement those together. Okay, so now there's an error that says cannot move out of index of this one because vector ordering does not implement the copy trait. Okay. So that line here, but that's fine. We don't want to move it anyway. and now it compiled. So let's run the test. Complained a lot, but the test passed. So, and here's the test. I create a comparison table, fill in some values, and then I check that I get the right values out. Okay, now let's implement less than. And it's the same pattern. So it's the same pattern. So let's do, let's make a new one that we just call get. And then it should also have an ordering. And then instead of this, we say ord. And that should be fine. And then here we say get. Actually, let's do this. Oops. Let's do this. Because now we can say get greater than element 1. So it kind of reads correctly, which is nice. And here we say get less than element 2. Let's run the test. And now the test is broken because we have to say get greater than. And it compiled. Does it also run the test correctly? Yes. And now we can easily write another test. Less than. And that should give the index 0. Okay. So now that's implemented. Now let's do the fill. Okay, so we have an element we want to fill in. So let's say row. Now it has to be a mutable reference to the values of that, and then we say for idx in 0 to row the length. Let's do the same here, because why have a variable when you don't need it? And let's say that again, if the index is equal to the element, then we can continue. And otherwise, let's look at the value. And if the value is unknown, that's great. It's not filled in. Then we can say row idx is equal to value. If, can I do this? Then it's fine, we don't need to do anything. But so if the value is already filled with the same value, but if it's a different value, then let's panic. Ideally you shouldn't use panic, but right, but whatever. Okay, so inconsistent data. And then let's format the table. So then if elements, can I do this, contains the index, then I want to do this, because I don't want to change all the indices, just want to change the ones that I give. So let's let's check it. Cargo check. And oops, it wants a reference, whatever. Cargo check. It stop. Emacs, please. It worked. We run it. It worked. We run test. It also worked. Okay. Now let's just write a test for that. Why not? Test fill. And we make a new table. We fill row 1 with greater than, and then we say, let me get greater than in row 1. Let me also get less than. In row 1. And of course, greater than should be 0, not 1, 2, 3. And less than should be the empty vector. Great. We test. It did not work. Okay. It's because we also have to provide the indices. So let's say 2 and 3. Okay. Test passed. We're very happy. Now we've implemented the greater than branch. And then we can implement this branch. Now, then we want to do the same, but just with the elements in reverse. So greater than element 2. Then we fill for element 1, greater than element 2, greater than, and less than element 1. And we fill those for element 2. Okay. Now, this is repeated code. So we should probably make a function. Let's call it apply comparison. Why not? And it will take apply greater than. This is a little bit weird. Right, we could do this. Not that, please. And then we define it here. Apply greater than. Mutable self. Element 1. usize. I mean, I guess it works. Let's try. It did indeed work. Unreachable pattern. Ah, okay, so this doesn't work. Give me a second. Okay, so this indicates that our test suite is probably not good enough. So let's make a test that should panic. And then we do like this. Comparisons. So 1, 2 should, if it's already less than, then this should panic. And I can get rid of that. And have to spell. Test should panic failed. Exactly. So a problem is that this val doesn't check if this value is equal to that. It just binds whatever is in row to this variable name. So I'm not exactly sure how to do it, but let's say if row idx is unknown, I think I have to use if instead of match, else if row idx equals value, then we don't have to do anything. Let's leave it as an empty branch for now. Otherwise, we panic. And now we can run the test. And it works. Great. Okay. So far, so good. Now, what do we want to do? Now we have the constraint propagation. Let's for fun run it a little bit. So we say, if we do this first, it's empty. Then we make a comparison between 0 and 1. So let's actually call. And also another thing we should probably do is say if element 1 is equal to element 2, then we panic. Don't compare elements with themselves. And then we say here, okay, let's add a comparison between 0 and 1. And the comparison is an anonymous function. Actually, let's just define it here because we'll be using it again and again. It will simply do this. If element 1 is greater than element 2, then it's greater than, else it's less than. Does this work? Let's see. Did not work. Okay, it wants us to borrow, whatever. Great. Okay. Now we add another one. And let's add 0 with 2. And then we should see that more than one square gets filled in because of the constraint propagation. Exactly. But now we see we have a bug because we compare here, then we should also fill in this one. Right, because it is already known. So let's go to the add function. And then let's just do it very simply. Is the opposite value. Actually, why am I doing it like this? Let's say value.opposite. And we can very easily implement that. Opposite self, match self, greater than, less than, greater than. Just for now, let's panic. Why not? Unknown ordering does not have an opposite. Great, we run it again. There's an error. It's because we need to return an ordering. Okay, perfect. And actually the bug was also there before. I just didn't notice. Is there another bug? So we say 0 to 2, then that fills in this one. And then via constraint propagation, we also know that 2 is less than 1. It doesn't sound right. So we have a bug. Apply greater than. So all the ones that are greater than element 1, they are also, so here we assume element 1 is greater than element 2. So if get all the ones that are greater, they should also be greater than element 2. All the ones that are less than element 2 should be greater than less than element 1. That looks correct. But then why does the algorithm think that 2 is less than 1? Let's go through the algorithm. So we add 0 and 2. 0 and 2. We compare, that should give 0 is less than 1. And then we put that in, put it in here. We put the opposite here. That's good. Then we say match with less than. And then we say apply greater than element 2 is greater than element 1. That's correct. Then we find all the ones that are greater than greater than 2. Yes, whatever it should give. Wait. Okay, so I think here's the problem. This is getting the elements where it says GT, but those are not the elements that are greater than element 1. Those are actually the elements that are less than. So I kind of like the way it reads, so let's do this. It's a little bit weird. Okay, now it just doesn't work at all. And it's because when we get here, element 2 is 0, so we say get the ones okay, but this is actually correct because we know that 0 is less than. Yeah, okay, so this is actually correct. Let's add a comment here. Let's add a comment here. We want to get elements that are odd compared to element but row IDX are elements that are let's say, but row IDX indicates that element odd row IDX. Okay. Okay, I hope it makes sense. Just a little bit of sense. But now so this case was actually bad because there's no constraint propagation. Let's do this. Then we know that how do we get constraint propagation to work? So then we know that 2 is greater than 1. Like this. Good. So now this should also add that 0 is less than 2. Okay, so first we say 1 is less than 2, and we also add that 2 is greater than 1. And then we say 0 is less than 1. That's great. We also add here. And then we also calculate that 0 is greater than 2. So again, there's something wrong. Okay, I think I found the mistake. So here we get all the elements that are greater than element 1, and then here for element 2, at these indices we fill in this value. So, but if these indices are greater than element 1, it means that element 2 is less than those. And the same here. So now, let me remove my debug code. Now it correctly says that 0 is less than 2. And now we have another problem, which is that we write less than here, but we don't write greater than here. But that's very easily handled. Down here, we simply say self.comparisons, and it should be like this. And it did not work. Second mutable borrow curse here. How do we do that? It's kind of weird. Let's try something like this. Please. Row is not found. And this one. Amazing. Now it works. And we do constraint propagation. Okay, let's try one more. What am I doing? Let's add 1, 3. Great. And now there's only one left. 2, 3. And the table is filled. So I think that's it for now, but you could also implement something that performs the optimal strategy. So you just, start at some random unknown value, apply the add function, then it will fill in some number of squares, then you take the next empty one, or random empty one, and you compare that, and so on. Then you will get like an automatic filling in the most optimal way, like the least number of comparisons that you can possibly do. Okay, but this was just a fun little exercise in constraint programming. See you next time.